Hello guys, how are you? So today we deal with physics. As you can see, we are given a Newton's law question. Oh, so guys, first thing essence we tlhaloganya ka Newton's law is to go through the statement. So they say a block mass m, they're talking about this block, is resting on a rough horizontal table. It's connected by a light extensible string passing over a light frictionless pulley to another block with mass of 260 grams. So guys, first mass guys from measure a kg. So we have to convert kilograms to what? To kg. To kilograms. Right? And how do you do that? We divide from here to here, we divide by 1000. But if we move from kilograms to grams, what do you do? We times by 1000. Can you see that? So what can we do? We can say 260 divided by 1000. We get what? 0.26. We get 0.26. Meaning here the mass is 0.26 kilograms. Right? Then they say the 260 grams, which is 0.26 kilograms, blocks hangs vertically as shown in the diagram below. Okay, a force of 60 newtons is applied to the stationary block. They're talking about this force, right? It's applied on a table at an angle of 10 degrees, this angle here, to the horizontal. It causes this block to accelerate at 2.89 to the left. So guys, first thing that you have to do here, before I start the question, you have to choose what? Choose the direction. We can say to the left as what? As positive, right? And then if left is as positive, meaning the right is going to be what? Right is going to be as what? As negative. And also what? Down as positive, and then up as what? As negative. It's important to choose the direction, guys. This direction will help you to do your calculations very well. So the coefficient of kinetic friction between the block and the surface of the table is 0.3. 0.3. That's talking about what? The coefficient of this block, right? Okay. Sharp. 2.1. The first question for 2.1, they say define the term normal force in weight. You know, the first question, guys, always is either they give you a definition, or you have to define a law, first, second, or third law, right? So just 3 marks. So let's define a normal force in weight. A normal force, guys, as you know, like it's a perpendicular force. Like we're talking about force, this force here, it's a perpendicular force. As you can see, it's perpendicular to this surface. It's a perpendicular force exerted by a surface, right, of an object. We're talking about this object in contact with what? In contact with the surface. That's the definition of what? Of a normal force. This is a normal force, right? The normal force. Here we can talk about Fg, right? So 2.2, they say calculate the tension in the string, right? They're talking about this string. So guys, what we can do this, right? We are given for block M. Okay, we can write block M. For block M, right, guys? And then for block M, guys, okay, we can say for block M, we can say the F net is equals to what? Is equals to MA. Mass times what? Times the acceleration. Mass times what? Times the acceleration. But remember the mass for block M, they didn't give us the mass. They just said the mass is M. So we can write what? We can write M here. And then the acceleration. The acceleration, they give us acceleration, which is what? 2.89 to the what? To the left. And we choose left as what? As positive. So when we are going to write, acceleration is going to be 2.89, right? But if maybe we chose to the left as negative, meaning here we were going to write what? Negative 2.89, right? And then we say what? F net, right? So guys, more F net, what do we deal with when we want the F net, right? We can check the first line exactly more this block M, right? Okay, let's talk about block M, right? Let's show block M here. F net and negative horizontal force, guys. We only want these forces, these horizontal forces only, right? As you can see, guys, first thing, the string, the tension, right? The tension, right? And then what do we also have? We have a force, right? That is applied. But that force, guys, we want this force, right? Here, but if like an angle, right? They've given us the hypotenuse. We can what? Get what? The adjacent, right? We want this force, meaning we want this force because we want what? The horizontal forces only, right? So we are given this 60 and this angle, so we can find this force here, right? That force applied, right? We can call it fx, right? So how can we get our fx, right? As you remember from mathematics, right, guys, we say what? We have mathematics, we have soccer, tower. What do we have here? We have hypotenuse. Okay, this is hypotenuse. Also, we have hypotenuse here. And then what do we want? We want the adjacent, right? What do we have adjacent? This. Or we are going to use what? Cos, right? This represents what? Cos, right? So we are going to say what? The cos of what? Of 10 is equals to adjacent over hypotenuse, which is what? Which is 60, right? Then we're going to do what? Cross multiply. It's going to be adjacent is equals to 60, the cos of what? Of 10. So the adjacent equals to 60 cos of 10. Cos of 10 it's 59,08846,518. So we can round it off to what? To 2 decimal places. How can we round? If maybe we don't know how to round this off, as we were taught, we can just say, you can just press shift and then mode, and then you go to 6, and then you press number. Which number do you want to round it off to? To 2 decimal. You press 2. Therefore, it have rounded to you. It's 59,09. If you didn't know about that, you can start using this so you don't get confused. Right? So, meaning we have what? Meaning we have the f at x. So our f at x here. Meaning we have f at x. And which force do we also have? Which force do we also have? Okay, we can check the other force. Oh, guys, as you can see right here, they say the coefficient of kinetic friction between the block and the surface of the table is 0,3. So meaning on this block, we also have what? The kinetic friction, right? Also what? The kinetic friction. We also have the kinetic friction, right? We have what is what we call what? Fk, right? What is our Fk? Okay, let's see. Our Fk here is how much? Fk is being given by what? The coefficient times what? The normal force, right? Okay, Fk is being given by the coefficient. What is our coefficient? Our coefficient is 0, what? Is 0,3. Oh, our coefficient is 0,3 times the normal force. Oh, what is our normal force? So we have to find our normal force, because here we don't have we don't have a normal force, so we have to find the normal force, right? Okay, guys. So the force is that, so the normal force is going to be given, right? N is equals to Fg minus Fy, right? You know, guys, Fg minus Fy. Someone can ask, why do I say Fg minus Fy? Okay, guys, as you know, sometimes let me do a little, what can I say, some drawings. When you have okay, can I say this, an object as in our surface, just like this, the normal force of it is going to just be equals to what? The Fg. But when we are given, okay, and then the object is on the incline, object on the incline, right? So what is going to be the normal force? The normal force is just going to be Fg perpendicular. The n equals to also Fg perpendicular. But when we are given an object also is being pulled at the angle, something like this, maybe 30 here. Then the normal force, it's what is Fg minus Fy. So why is it Fg minus Fy? Because of here we have what? We have Fg, right? And then here's what? The normal force. So Fg must be the all forces that's what let's say right? So it's what? The normal force, so it's Fg must also is equals to what? N plus also the other force that's going up is this force here, this on this triangle. So it's what? The Fy, right? So the normal force, regard Fg, bring this to the other side, is minus Fy, then the normal force. So that's why the normal force equals to Fg minus Fy. Did you see that? Yes. So the normal force is equals to what? Is equals to m, because Fg is the same as mg, the mass times axle times what? 9, what? 9,8. Right? The gravitational force minus Fy. Did you see that? Okay, guys. Oh, so I made a mess. So I apologize about that. Let me bring this here. So the normal force equals to 9,8 m minus Fy. 9,8 f m minus Fy. How can we get our Fy? Fy, we are talking about which one? We are talking about this one. Talking about this side, right? We have what? We have 60, and we have hypotenuse and opposite. So we can use what? We can use sine from, as you can see, right? It's opposite and also what? Hypotenuse. So we're going to say what? We are going to say the sine, we are calculating for Fy, right? The sine of what? Of 10 was to what? Opposite, which is Fy, over hypotenuse, which is 60. We do cross multiple. Fy equals to 60, the sine of what? Of 10. Then the Fy is equals to what? Is equals to what? 60, the sine of what? Of 10. 10, what? 42. 10, what? 10,42. Did you see that, guys? Okay. Yes, we can move on. So meaning the normal force, guys, I know I made a mess, sorry here, so I apologize. It's what? 9,8 m minus 10, what? 42. Yo, I made a serious mess here, guys. I apologize. Minus what? Minus 10,42. Okay. So meaning we can go back to what? To our Fk, where it's coefficient times the normal force. So Fk is equals to what? Is equals to 0,3 times the normal force, which is 9,8 m minus 10,42. Right? So we can say right now, we'll term this with this, right? We're going to say 0,3 times 9,8 gives us what? 2,94. So get what? 2,94 m. And then also we're going to say 0,3 times what? Times 10,42 minus 3,13 minus 3,13. Right? So Fk is what? It's 2,94 m minus 3,13. So we got our Fk, we got our tension, we got what? Our, so it was what? It was what? Okay, guys. So guys, here I was just trying to, okay, we could have got tension by using this one here, right? So here I just wanted to get over this one, the F net of this one. I know we could get tension easily, so easily, by using this object here for 0,26 kg. It would be easy, right? Okay, right? So this was just the object where we have what? The tension, and also what? Fk, and then here we have what? F applied. So right, remember we chose left as what? As positive, meaning this one is going to be positive, and then this one is going to be negative, this one is going to be negative, right? So our f net, if you can remember our f net was f net is equals to m acceleration, which is 2,89. So the f net right now is going to be what? F applied, our f applied, it's how much our f applied? It's 59,09, right? Minus the tension minus fk. Minus fk is how much? Okay, it's going to be, oh guys, it's minus, we put this in a bracket so we don't make a mistake, m minus 3,13, right? Close the bracket. Force applied tension, frictional force is equals to what? 2,89 m, right? As you can see, right? So what can we do? We can say 59,09 minus tension minus 2,94 m plus 3,13 is equals to 2,89 m, right? And we can take this to the other side, and we can have what? Oh, we have 59, can add like times 59,09 plus 3,13, which gives us what? 62,22. We have 62,22, right? We have added this and this, we can add this and this, so it's going to be minus 2,94 minus 2,89. It's minus 5,83. It's minus 5,83 m is equals to the tension, right? So guys, as I told you, this was for what? It was for block M, right? As I told you guys, we could have gotten the tension just by using this block here. I've just this block here because I knew it was a long process. So right now we can go for block for 0,26 kilograms. So the forces, it's what? We have FG, we have the tension, right? So we can say what? The F net is equals to MA, right? So we chose what? Down as what? As positive, up as what? As negative. So as you can see, well guys, this force is being accelerating to the what? To the left, right? So if it's accelerating to the left, is being pulled to the left. Therefore this one, meaning meaning this one is accelerating what? Upwards, right? So meaning upwards, right? So we have what? We have our tension. So our tension, as you can see, so meaning upwards arrow is going to be negative minus tension. So we're going to have minus tension plus Fg is equals to what? 0,26, because it's accelerating upwards negative, or globally minus 2,89, right? So minus tension plus Fg, we have 0,26, 9,8 is equals to, let's times this one, 0,26 times 2,89, negative 2,89. What do you get? 0,75. We get 0,75 minus 0,75, right? And then what do you have this side? This side you have minus tension, right? You have minus tension plus, what do you have? 0,26 times 9,8. 9,8, 2,55. 2,55 minus 0,75. Oh, this is comma, guys. Sorry. 0,7. 0, what? 0,75. Therefore, we can say 2,55 5 plus 0.75 is equals to tension. What is our tension, guys? Our tension is 2.55 plus 0.75. Our tension is 3.30 Newton. So guys, I knew I took a lot of time to calculate the tension, but for the tension you can just say I just wanted to get over this calculation for this block. So for, okay, let me do this. You just can say this is for 2.2.1 exactly. The tension is 3.30, right? And then I just wanted to get this done. So guys, how can we get this mass here? And then just check the last question. They're saying calculate for the mass M. Already for block of mass M, we have 62.22 minus 5.83 M is equals to tension. What is the tension? The tension is 3.30. So what can I just do? Actually, I know I've messed. It's a mess, guys. I apologize for this mess. So what can I do? I can say 62.22 minus 5.83 M is equals to 3.30. Do you see? And then what can I do? I can say 62.22 minus 3.30 is equals to 58. This is 58.92 is equals to 5.83 M. So I'm going to divide both sides by 5.83 M. 5.83. Sorry, 5.83. So we're just going, this is going to cancel. We are left with the mass. And then what is our answer? Our answer is 58.92, 5.83, 10.11. So the mass is what is 10.11 kilograms. So yes, guys, we are done. I know it took a lot of your, right? Yeah, I just wanted to show you this, guys. Yeah, so thanks for watching. I hope you understood. If there's a question that you didn't understand, please comment down below. I know guys can mess here and I apologize for that, but if there's something that you didn't understand, please comment down below. I'll try to explain again. Thank you.